La siguiente charla estará a cargo de James Ballan de FL Smith, quien nos va a hablar acerca de la reducción de riesgos introduciendo la puzolana sintética.
Good afternoon, everybody. Thank you for coming in after the break. And not everybody is here, so I'm going to try and stall as much as I can to hopefully more people come in. But I'm going to get in trouble if I don't start soon. So, my name is James Ballan. I've been with FL Schmidt now for 15 years. Spent many years in the field, startup, commissioning, optimizing cement plants. And I spent 3 years from 2008 until 2011 in Brazil, working with many cement producers to optimize their system. And when I was in Brazil, I came across these wonderful products that seems only cement producers in Latin America are utilizing in great amounts, and those are SCMs. Today, I want to talk to you about reducing risk when introducing synthetic pozzolan. Now, why am I focusing on this? If you were here at the APCAC last year, you heard me talking about SCMs. And the reason there's a big focus on SCMs is every global forecast is showing that clinker is reducing in quantity in cement. Within the next 10 years, the global cement production is going to contain only around 80% clinker. In the next 20, 30 years, that number is going to go down to 70, maybe even further. But the world is slow. I've been talking to cement producers here, and today in Latin America, cement is averaging around 80% clinker. And the rest of that material is SCM. So why only 20%? The reason is there is only a limited availability of these SCMs. So what are SCMs? The reason I use that term SCM is because it stands for supplementary cementitious materials. And if I had to say supplementary cementitious materials every time, I would be here until 6 o'clock tonight. So what are SCMs? SCMs are any material which can take the place of clinker in cement and has cementitious properties. Those materials can be any material found, but we can categorize SCMs into two categories. They're either a hydraulic or a pozzolanic cement. What is the difference? Hydraulic SCMs, when mixed with water or hydrated, they form the bonds and build strength. Pozzolanic SCMs need to be present with either a lime or a calcium in order to build those strengths. Today, we look at 3 types of SCMs. The 3 types of SCMs are natural and synthetic SCMs or waste materials. And I don't have to tell cement producers in this room, but the benefits are phenomenal. Lower cost, lower fuel consumption, very high environmental benefit for utilizing SCMs. And you can incorporate them with a very low capital cost. So what are the ones that you're using today? You're familiar with these. Fly ash, slags. Very limited people are privy to natural SCMs, so the focus is on using waste material, like here. But just like the cement industry is changing, the industries that produce these materials are also changing. Power plants are coming under increasing pressure to reduce their emissions. And when they reduce their emissions, the fly ash gets dirtier and dirtier. You have to deal with things like carbon, ammonia, and mercury in the fly ash. When the world economy crashed several years ago, steel producers, they kept going. And why? That's because China was sucking up all of the steel production in the world. But they've reached a plateau, and their consumption of steel is starting to decrease. And the world economy hasn't recovered, so there's less and less slag available. And the slag which is available is getting more and more expensive, just like the silica fume. So what do? We can't go back to using 90–95% clinker. It's too expensive. What we can do is we can start looking at some of these synthetic SCMs. The one I want to talk to you about today is clay-based SCMs. How do we make clay-based SCMs? Well, clay is a very crystalline structure. It's very organized. It has high amounts of aluminates and silicates, which can react with cement, but they're trapped in this nice, organized structure. But if we add heat to it, we can actually pop that structure into an amorphous material, which is very unorganized. And those silicates and those aluminates come to the surface so that they can react with the calcium hydroxide in cement. One of the problems when creating or producing clay-based SCMs is there's a limit. If we add too much heat, we go back to a melted state. The clay melts and collapses on itself, and it goes back to this organized structure, which is not reactive. If we can target that amorphous material, we can get a very highly reactive material. How reactive? Well, if we look at traditional SCMs in a binary mix, 30% SCM and 70% clinker, slag and fly ash reach about 90% of OPC strengths, which the market accepts. Clays, on the other hand, are very unique. There are many species of clays. If you're lucky to have one of the best species, a kaolinic clay, when we heat treat that kaolinic clay, we can mix it 30% clay-based SCM with OPC, and we can reach almost the same strength as OPC. But if you go digging in your quarry, you will be very lucky to find only one species. Typically, you'll have a ternary mix, which means there's several different types of clays in the ground. And when you heat treat that and you mix it with clinker, you get strengths that vary from 70% up to 90–95%. That's not good enough. And the reason it's not good enough is because you cannot take a clay-based SCM and mix it directly with OPC. Why? Well, the reason is the blended cement with clay-based SCMs is completely different. Clinker was engineered to be the sole component in OPC. when we start adding other components, we have to optimize that blend. And the only way to reach higher substitution rates is by optimizing the hydration. Only if we optimize the physical and the chemical characteristics of the blended cements can we make a blended cement which mimics ordinary Portland cement. So when you start looking at clay-based SCMs, you have to deal with things you're not accustomed to dealing with fly ash and slag. You have to deal with the strength development. You have to deal with the water demand. A lot of clays come with iron, so you have to deal with the color. How do you know if the clay in your ground or near your cement plant is good for making a clay-based SCM? Well, you go out, you grab a sample, and you take it back to the laboratory. And you actually produce a synthetic pozzolan with that clay. You do various tests. You characterize the material. You prepare it. You test it in the raw state, and then you heat it on a desktop oven. You produce a synthetic SCM. You find the right parameters to control the color. And then you grind it, and you mix it with OPC. And you test the strength. And typically, people will test the strength in various ratios in order to find the best ratio for your cement plant. This is what you can do in your own lab. This is what every manufacturer, OEM manufacturer can do. There's independent labs that can do this. There's universities that can help you do this. And that's great. We can optimize this SCM. But can you convince your customers that what happens in your lab is correct? I was talking to a cement producer yesterday, and he said that customers do not buy their one-piece cement. And the reason why is because they don't like it. Why? Is the strength not good? No, the strength is good. We tested it in our lab. But the biggest hurdle to overcome when introducing new products is market acceptance. And the reason I'm preaching in front of you today is I want to introduce you to a new approach in order to reduce your risk in this category, market acceptance. We have manufactured a new way to gain this market acceptance. And the way that we can help you to do that is with a simple concept. It's a mobile plant. This is a plant which is based on the industrial size calciner system, made smaller, so the production is less. You can produce 5 tons per day of synthetic SCM with this system. Fully integrated, fully functional, just like an industrial system. But the advantages of the mobile system are hands-on experience, production of sufficient quality and quantity of SCM. So you don't have to tell your customers, this stuff is good. You can say, here, this is what I want to produce. This is what I have available for you. And you can work to overcome that market acceptance and the risk of making a large investment which will not pan out. What kind of investment are we talking about? Well, an investment in something like this is less than 1% of an industrial system. Every project, every future business engineer can benefit with these types of concepts. A mobile plant, very small investment, and you can gain market acceptance before you make the investment. So what does this look like? Well, here's a 3D rendition of the mobile system, which is specifically designed for clay-based SCM. It fits in two 40-foot container size structures, has all of the processing equipment from material preparation, material feed, heat treatment, color control, and cooling, all integrated into this compact system. The third container houses all of the parts that you see hanging out of these structures, plus the control room, the air compressor, and the generator to supply power for this system. Using concept and using technology, we can overcome the risk of introducing new products, one being calcined clay or synthetic SCM. Also, we can utilize this to help you improve other SCMs, the natural or waste materials. I want to thank everybody for coming in after a break and at the end of the day. I look forward to talking to you after if you have any questions. Thank you.
Gracias, James.